So by the end of this lesson, this is a developing one, recognize type of factorizations. So hopefully you'll continue to develop that. It's okay. Remember, as a mathematician, it's not a thing where you just know it and then you're perfectly formed when you walk into the classroom. Otherwise, I'd be out of a job. So I'm really pleased that people haven't got there yet, because otherwise I'll be out of a job. But you need to develop the skill of recognizing types of factorization. So if, for example, you saw that there was a highest common factor of 3, you've just recognized something in the problem before. You just recognize that there's a highest common factor of 3. That's to be celebrated as well. The next level, though, is did you recognize this? This is a few levels on. Was actually a difference of 2 squares as well. And if you did, that's definitely something to be celebrating. That's really good. That's where everyone needs to be, where they can sort of start to see that there's a pattern there. Even if you don't always get it right, if you know that it's a difference of 2 squares, that's at least a start in the right direction. So that's what the first thing I want you to do, be able to do. Develop that as you go along these lessons. Second one, and this is the main learning for today, is you can factorize a monic trinomial, and we'll go through what that means in this lesson. Let's have a look at this one. These problems come from the sheet that we worked on last week. So homework was to work on all of the difference of 2 squares problems and the perfect square ones as well, was it? I think from that sheet. It was on Google Classroom. There's no real reason why you shouldn't have, that you didn't know or anything like that, because it was on Google Classroom with the specific letters that you had to do. So what I'm going to do is I'm going to pick the 4 that were the trickier ones. They were the ones that were labelled as uber hardish, and I'll show you how to do them. And we'll start off with this one, x minus 2 all squared minus 9. Most people's initial reaction is to expand the x minus 2 all squared. Okay, but if you did that, you've missed a trick. Because, again, this is really like an A standard thinking here, because it's unfamiliar. What you need to be able to sort of step back and see is that as a mathematician, fitting a pattern is something, looking at something and seeing that it fits the pattern it sometimes is not obvious. In this instance, x minus 2 is an expression, sure, but ultimately it's something squared. And minusing it is something else squared, 3 squared. So we've basically got 2 things that are squared. We've got, I'll do it in a different colour. A equals x minus 2 and b is equal to 3. So x minus 2 squared minus 3 squared. And the rule is a minus b times a plus b. That's applying the rule. And so that would be a minus b, a plus b. Does that make sense? I haven't finished yet, but does that line make sense? Just because it's not a simple thing like x or 3x or whatever, it doesn't mean that the rules for maths suddenly change. We've got something squared minus something else squared, and so we can do this. And that's equal to, I'm just going to simplify now. I can subtract 2 and subtract 3. That's minus 5, right? And I can subtract 2, then add 3. That's going to be plus 1. So it's x minus 5 times x plus 1. Now, if you did it long ways, you would have expanded the x minus 2 all squared. You would have then got a plus 4 at the end, which you would then subtract 9 to get negative 5. That would have left you with a trinomial, and then you can use trinomial factorization in order to complete the problem. It's doable, but I don't know if it was this class or the other class. I think it was this class I said. So I talked about going via Queenstown, didn't I? Yeah, going to Launceston via Queenstown. So if you expand the square and then simplify and then use a trinomial factorization, you will get the same answer, but it's like you visited Strawn on the way to Launceston. Okay, you'll get there, but it's the long way around. If you can, the next 3 problems are actually fairly similar in that they just use the same idea. So if you want to, try and work faster. I'll zoom out so you can see all of them at once. These are the ones from the sheet. I haven't made any of these up. You can see the letters there that are used. But yeah, if you're watching this at home, people who are watching the video, feel free to pause it and come back. So again, in your head, I'm going to do it in red pen so that you can see it, but in your head, you identify what A and B are. A is x plus 3, B is x minus 1. And so we end up with A minus B, there's A, minus B. Now, when you're subtracting in a complicated expression, use more brackets so you don't get confused. I'll show you what I mean by that when I finish off the problem. X plus 3 minus x minus 1. X plus 3 plus x minus 1. Now, the reason why the brackets are important is because when I subtract a negative, I'm going to get a positive. So watch what happens when I take out these brackets now. Minus x is minus x. Minus 1 is plus 1. So that's my full expression there. And then with this one, it's not so hard. Plus x is plus x. Plus minus 1 is minus 1. And then finishing off the problem is just simplifying. I've got x minus x is 0. 3 plus 1 is 4. So I'm actually just left with a 4. No need for brackets. Outside of x plus x is 2x. 3 minus 1 is 2. Oh, I've got a bit more I have to do after that. Yep, well done. I don't have room to put it on this slide, so I'm just going to do an arrow. So there's a common factor of 2 there. So I'm going to have, I'm going to have 4 times 2. I didn't mean for this to be this complicated. Outside of x plus 1, which is 8x plus 1. I'm going to zoom up so you can see that. I didn't mean for it to be so complicated. Okay? So that iterative process again, where I've got this far and I've gone, oh, I've got something that can be factorized here. It's a common factor of 2. So I've brought the 2 out. And because I brought the 2 out, I need to write the multiplication sign in. I could have just done this in my head, by the way. I could have just gone 2 comes out, so that'd be 8. That'd be fine. But to write it explicitly, I have to have the multiplication symbol that was implied before now written out. So that might look like a few steps to you, but this would be what you'd have to do without that. You'd expand x plus 3 all squared. You'd expand x minus 1 all squared, keeping in mind that minus sign is going to change all the signs in the expansion. Then I'd collect like terms. Then I'd need to see that there's a common factor of 8, and then I would be left with the x plus 1 after all of that. So that might look like the long one. That might look like the strawn route, what I've shown you here, but it's only because you're probably not used to it yet. The more of these kinds of problems you practice, the better you are at it. The better you are at it, the more likely it is that you'll be able to zoom through that. To be perfectly honest, if it were me, I would have done this line, and then I would have probably done that line, and then I would have done that line. So I would have done it in 3. 1, 2, and then 3. 3 steps. And you can do that too. One of the things you need to be, which goes against what I normally say in regular maths classes, is I actually want you to apply the shortcuts. I want you to see the patterns and then just do it. Okay, in regular maths classes, I might be saying, I want to see more steps. I want to see more working out. I want to see your thinking. But I actually want you to train yourself to actually do some thought stuff in your head. Here's the other 2 that were supposed to be a bit tricky. And maybe they're not so tricky now.
I didn't get that.
Oh, silly
Try
shush.
again.
So this one, what have we got? We've got, again, we do this in our head. A equals 5, B equals x minus 1. And again, with more practice, we would just get into it. We would just go 5 minus x minus 1. Naturally, I put brackets in there because there's a minus of a minus. I don't want to get myself confused. 5 plus x minus 1. And that's, let me see now. I might skip that step so you can see what I mean. I'd now just go 5 minus x and minus 1. Well, that's going to be 6. Minusing a minus 1 is a 6. So I'd go 6 minus x for the first one. And I'd go 5 plus minus 1 is 4. So I'd be left with 4 plus x as my second one. And that's just the faster way of doing it. I've just not done some of those middle steps there. Okay, before I do beta, that was alpha I just did. Before I do beta, does anyone have any questions about that? I deliberately missed a few steps there. So if you're doing it yourself and you put those steps in, I think you'll see where I came from if you can't see it right now. Last chance for a question? Okay, moving on. This one's just a little bit different. Little bit different. What makes this a little bit different? Sorry, Remy? It's not a square number. Neither is 3 outside of x minus 1 all squared. Remember, that's a whole unit. 3 outside of x minus 1 all squared is a whole unit. So although this bit is squared, the whole unit's not squared, if you know what I mean. Okay, think of multiplication like glue that mushes all the unit together. So I've got 3 outside of x minus 1 all squared is a single unit there. And it's not a square. Just like 3 4s are 12, 12 is not a square, even though 4 is. Sam? Good thinking. I'm going to just change what you said a little bit there. You can't divide by 3 because you're thinking like an equation. Like if there was an equals 0, then you could divide out the 3. But you can definitely take 3 out as a common factor. So good thinking there. So if I do take 3 out of... So basically what I'm doing here is I'm saying, this is not a difference of 2 squares, but it nearly is. I wonder, is there something I could do to make it into a difference of 2 squares? And if we look at our list of things we should be trying, our first one is HCF, right? Highest common factor. And I can definitely HCF this because it's got a HCF of 3, as Sam said. 3 times what equals 27? Yep. So, and 3 times what equals 3 times x minus 1 all squared? X minus 1 all squared. Now I've got a difference of 2 squares. I've got 9 and x minus 1 all squared. Now I'm going to struggle to fit this in this little box, so forgive me for being a little bit squishy here. So that's going to be 3 outside of, now 9 is 3 squared, so it's going to be 3 minus x minus 1 and 3 plus x minus 1. And I'm just going to fit it in this little squishy box here. And that's equal to 3 multiplied by, so 3 minus minus 1 is 4. So 4 minus x multiplied by 3 minus 1 is 2. 2 plus x. And that would be the fully factorized version. That's why they're sort of uber hardish, I suppose, because there's a few steps to them. But every single individual step's not that hard. It's just putting it all together to get the final line is where it gets a standardy, you know? All right, I'm going to move on to some more stuff. I'll just show you all 4 slides at once. I know it's a bit... Oh, I had more room down there. Anyway, I know it's a bit small, but nevertheless, questions to be asked before I move on. Look at what? Oh, not me. Harsh, man. I'm just trying to teach. I apologise. Okay. Here's a reminder. They're the steps, kind of. Always, always, always HCF it. If you can HCF it, HCF away. Number 2, perfect square and dots. Check to see if it fits the pattern or not. We know perfect square needs 3 terms. We know the first one needs to be a square. We know another one needs to be a square, and we need to know that the third one is mush them together, double it. Third one, trinomial factorization. We're going to tackle it over today and tomorrow. The fourth one, usually if there are 4 terms, there's a good chance there's a grouping method that can be used there. I'm going to use grouping again today, actually. And number 5, because I want it to be complete, other techniques. You don't need to write any of that down. We've written them down before. But in slide 6, it says Monic factorization. And it says underneath that, Monic with ax squared plus bx plus c ... And I'll finish it off in a second because that should be written into your summary book. I'll be precise because people weren't paying attention, I suspect. Write that into your summary book to start with. I'll give you 30 seconds to get it out and written down. I say 30 seconds, I mean a minute. Okay, so when you hear the word monic, like a monic trinomial, it's pretty simple. It just means with ax squared plus bx plus c, a equals 1. Yeah? So remember that 1 is an implied value. So x squared plus 2x plus 3, the implied coefficient of x squared is 1. Okay, we don't write 1x squared plus 2x plus 3. We just write x squared plus 2x plus 3 because the 1 is implied to be there. It's an invisi 1. 2x squared plus x plus 1 is non-monic because the coefficient of x squared is 2. X squared on 2 plus x plus 7, the coefficient of x squared is... I've got it in the non-monic section though, so it's not 1, is it? Starts with point, ends in 5. 0.5, well done, Sam. A half, yeah, it's a half. Because I can pull out that divided by 2 and just say it's a half times x squared, right? So it's whatever times x squared. So it's a half times x squared, which we can write as x squared on 2. That's what I put that example there deliberately, knowing that it wasn't obvious. I wasn't trying to I wasn't trying to pretend that it was obvious. It's not. That's why I put it there. So x squared on 2 means a half times x squared. So it's a non-monic. Okay, simple as that. So I'm just going to do it by example. So I'll zoom out and keep it zoomed. Keep it zoomed out. Example 1. I'm going to show you how to do. I'm going to show you how to do this method by what we call. What's it called? It's not deconstruction. It's something else. Decomposition. As you can see, I've got a trinomial here. It's a perfect square, right? So hopefully we're getting to the point where we can see x squared plus 6x plus 9 and know what this is as a factorization without doing any work other than head work. Okay, do you reckon, is there anyone here that can call out what they think that is? You got it, Sam. Well done. X plus 3 all squared. Can you see that? That's x, that's been squared. That's 3, that's been squared. 3 times x is 3x, double it, you get 6x. Is that okay? Yeah? Oh man, guys, you don't give me anything. Honestly, you guys could be thinking Richard's talking in a different language or Richard's going too slow or anything in between. I got no idea. I need some feedback, even if it's just nods of heads so I know that you understand what I'm doing, or shakes of head so I know that no one's getting it. If I look around the room and I see multiple shakes of heads, I can then rephrase it. I'm pretty good at that. Oh man, come on, guys. So x squared plus 6x plus 9 is x plus 3 all squared. Okay, I'm going to take that as a given. So we know that. I'm using this to illustrate the decomposition method here. Watch what happens when I decompose the middle term. So I'm going to say that's equal to x squared plus 3x plus 3x plus 9. So remember that that's just double. Remember how, like in perfect squares, we're doubling to get the 6x? So I've now undoubled it and separated it out as 3x and 3x for a good reason. Can you please see how you go with this? I'll give you 30 seconds to do it only, so you're not going to be stuck for too long. Use factorization by grouping, by pairing those two up and pairing those two up. Go. So you're factorizing by grouping. Remember, you pick a pair of terms, you take the common factor out of that pair, do the same thing with the other pair, and then hopefully you'll have another common factor you can pull out. 10 seconds left. If you don't understand, it'll be made clear. Well, hopefully it'll be made clear. I won't know because people won't tell me. Okay, so let's see how you went. For the first two terms, the common factor is x, and that leaves me with x plus 3 on the inside there. X times x is x squared, x times 3 is 3x. For the second one, I've got 3 as my common factor. 3 times x is 3x, and 3 times 3 is 9. If I then take out the common factor of x plus 3, I'm left with x plus 3, which is, of course, as we know, x plus 3 all squared. So there you go. So decomposition basically means split this up so that we can get a common factor. So that works with perfect squares. It works with a bit of trickery for difference of two squares. And it works for lots of other monics that don't fit into any of our patterns yet, which is what we're going to have a look at next. So example 2. X squared plus 5x plus 6. I'll try and express why this works in a moment, but just bear with me. I'm going to split up the 5x. I'm not going to halve it because that's not going to be very helpful. I'm going to halve it in this way, and remember I said I'll explain this later. I'm going to split the 5x into 2x and 3x. Is that okay? Why? I'll explain later, but bear with me for the time being. So the first term stays the same, and the last term stays the same. So I split the 2x and the 3x up, and I've got a 6 there. Now, if I use my grouping method again, I'll have x outside of x plus 2 for the left, and I'll have 3 outside of x plus 2 on the right. Good news, we've got a common factor of x plus 2, and it leaves us with x plus 3. I'm hoping you're experienced enough with the grouping method for me not to have to spell out that, but if you personally think you did what now with a how now, then just let me know later and I'll go through it with you individually. But that's it. That's the problem done. We've now factorized it. Remember, factorizing means expressing as a product. We've gone from an expression, 3 things added together, x squared, 5x, and 6, and we've ended with x plus 2 multiplied by x plus 3. That is factorized. It is now expressed as a product. You can see the next thing I'm going to do is reverse box method, but does anyone have any questions over that before I do the reverse box method? What's that? Why did I choose 2x and 3x? That's a really good question. Thank you for nobody asking that. There is a there is a more technical answer for why it works, but I'll see whether you can see the relationship yourself. What is the relationship? Look at the numbers only. What is the relationship between 2, 3, and 6? Hugo. Oh, sorry. I forget that sometimes I'm doing stuff that you've done. Please tell me if I've already done. What is the relationship then? Hugo? Sorry? Get 6. Yeah, cool. I'm so sorry. I forget that you do things. I always go back to basics, forgetting that you've done things in maths. This is one of those times where you're always welcome, and thank you, Hugo, but everyone's always welcome to say, we've done this already. Can we move on a bit faster? So I apologise for that. Let me just spin on then. I'll do this really quickly then, just for completion more than anything else. So you've done reverse box method? Okay. So really quickly, doesn't hurt that you see it again from my perspective as well, but nevertheless, it's a bit of a waste of time, so I apologise for that. So we've got reverse box method. We've got x squared as being the squared term. We've got the constant term, which is 6. Constant simply means there's no variable in it. So 6. And then we are figuring out, I wanted to do more than that. Then we're figuring out what the two numbers are that go either side of the that multiply together to give me 6. So we know that x times x equals x squared. We know that 6 times 1 is equal to 6. So is 3 times 2. So it's a matter of picking which pair. And of course, with practice, you can figure out which one works. So I'll go plus 3 here and plus 2 there. And that'll give me plus 5x if I multiply these out. And that is the middle term that I'm looking for, plus 5x. So I can put a tick there to say, yep, that was right. And so the factorisation is x plus 3 times x plus 2. And that's all there is to it there. Just give me 1 second, though. I had something that I wanted to go through with you guys, but I wasn't sure whether... Can you just confirm for me? Can you do, please... I'm going to make one small change to the problem, and I want you to use whatever method you want to solve it, and we'll talk about it in a minute or so. So it's x squared plus 5x minus 6. So I'm going to pause the video, have a go at doing that now, please. Okay, did you get x plus 6 times x minus 1? You did? Well done. But the reason why I made you do it is because I wanted to highlight that it's an example of where the reverse box method, or by decomposition, becomes a little bit arduous if you don't see it straight away. Because if I did the same thing here, I would have x squared here, I'd have minus 6 here. So I would start with 3 times 2, of course, because 3 2s are 6. But I then need to make sure that one of them is negative, because a positive times a positive is equal to a positive, and a negative times a negative is a positive. So I know that one of them has to be negative. So it could be either minus 3 or positive 2, or it could be minus 2 and or it could be positive 3 and minus 2. It could be positive 6 and minus 1, or it could be minus 1 and or it could be minus 6 and positive 1. So there's actually 4 options there, just that you'd have to work out the combinations of in order to work out the right combo. Now, the good news is with monic factorizations, it's actually not that hard. It's like, well, I need 2 things that will add up together to give me 5. One of them has to be negative, so that's going to be 6 minus 1, right? So then you go for it. Now, again, I just want to point out really that I'd forgotten that you would have done some of this already in regular maths. But the point is that the reason why add 2 numbers together, 2 numbers that will add together to give me 5, that will multiply together to give me 6. The reason why that works is because of decomposition. This is the reason why. It doesn't hurt for you to see that. That unpacks why that works. The reverse box method, if you're a visual learner, then seeing a box in front of you is really useful for you to be able to break that down. Having said that, though, as Maths Extended students, not necessarily now, but by the time it comes to test time, I would hope that you can take that problem and go straight to the answer by thinking in your head, what 2 numbers add together to give me 5 that multiply together to give me 6? Yeah, I'm giving you permission to do less writing down. For monics, tomorrow we'll look at non-monics, and you will need to do some writing down for that. Yep.
When will we practice this?
Not for a couple of weeks, and I didn't mean to make this a surprise, but I'm going to give you a quiz on Thursday. I don't mind if you don't study terribly hard for it, because really I want the quiz to be how much do you remember and how much is solid with you and what do you need to keep on practicing. Yeah, so thanks for the question. Did everyone get that? Quiz on Thursday. So yeah, sorry, there's a lot of work for something that you already know how to do, but importantly, the message out of this is I do expect a Maths Extended student to eventually get to the point where they can go from here to there without any other working out. So in other words, you're doing it in your head. All right, so we've got 15 minutes left, but you should be well practiced at this. I'm going to hand out a puzzle sheet, and you can see that I've got some particular questions I want you to do. They're all monic, so it shouldn't be too hard for you. And then tomorrow we're going to have a look at non-monics, and that'll basically finish the pattern, finish the rules that you need to learn. And I'm going to teach you a special way of doing non-monics, which you wouldn't have come across before. Okay, so I'll hand out those puzzle sheets, and away you go.